Welcome to video 10 of tasks in Scala. Today we're going to be talking about inheritance. Maybe sounds like a difficult word, but you will soon see what it is. Okay, the task that you will be doing after this video is to help out a travel agency, storing information about their travel packages. Each travel package has a name, a price, and a destination. And then there are 3 different types of travel packages: the tropical jungle, snowy week, and the city tour. And you will be creating all the necessary classes using inheritance. And you have to create at least 2 class instances of each different travel packages. And well, the rest of the information I will give you later, but then you already had a little sneak peek of what's to come. So as always, I would suggest you ride along. And before we get started on inheritance, I want to talk a little bit about classes, because classes are of the utmost importance in Scala. As you know, a class instance is an object, and Scala is an object-oriented programming language. And you often will see this abbreviated by OOP, so object-oriented programming. And that basically means that you structure your program into objects. Practicing here, we haven't seen that so clearly because we are working in a worksheet, as you can see over here in Scala. But once you start creating bigger programs, a bigger backend, then you will definitely structure your program into objects. Now, you don't have to remember all this, you don't have to understand all of this. It's just good for you to know these terms, because once you start Googling or once you start reading more about Scala, I will definitely talk about OOP, object-oriented programming. And in the future, I will definitely share more about this. And another comment would be that Scala actually combines object-oriented programming with functional programming. So once again, we're not going into this, but just so you know these words, you know they have to do with Scala. Let's just get started with the topic of today, which is inheritance. And why did I actually talk about this? We're going to talk more about classes right now. We're diving deeper into classes. So now you have an idea of why are we focusing so much on classes? Well, that is because classes are the templates for objects, and Scala is an object-oriented programming language. So this is super important in Scala. Okay, inheritance. Let's go back to the topic. Inheritance is also, a normal English word, and you could define it like this. Inheritance is the process by which genetic information is passed on from parent to child. And actually, we use it quite similarly in programming. So we would have a parent class. We don't actually call it parent class usually. That's why I put the double quotes. And then you would have the child class. So the names that usually are used for this are superclass and subclass. And the child, so to say, inherits all fields and functions from the parents. Let's just look at an example of how this works. So, for example, we have the class animal, which has the parameter name, and it also has a function that's called eats, which will print yum, yum. So this would be the parent, this is the superclass, and now we're going to create 2 subclasses, which I'm going to make case classes. First of all, a cat, so this has a name, and then we have to use the keyword extends animal, and we have to pass on the name. So we have the case class cat, which receives a name as an input, and it extends animal class, which also expects the input name. So we pass on the name from here to here. So in this case, the cat is the subclass and the animal is the superclass. Let's write it like this. Okay? Now we can also make another subclass of animal, which we're going to call dog. Once again, we pass the name, and we're going to say extends animal, and we pass on the name. So let's create some objects from them. We create Oli. He is a cat with the name Oli. And we're going to create Sami, a dog with the name Sami. And then we're just gonna let Oli eat and let Sami eat. And as you can see, they both print exactly the same thing because they use the same function. So both of these classes, because they are subclasses of the animal class, they have access to this function and it does exactly the same thing. So that's the basic idea of superclasses and subclasses, and this principle we call that inheritance. Now we're going to look at a larger example with some more information that I'll pass on along the way. We're going to start with a class product, and the product has a name and a price. The price is a double. And we also have a function that's called printMe, and it will just print an interpolated string with the name and then the price between brackets. Yes. Okay. As you know, I'm quite fond of coffee shops, so we're just going to continue with that. We're going for a Frappuccino. We are creating a case class Frappuccino that will receive a flavor. And this time, we're not going to put the parameters of the parent class in the subclass as well, because they are going to be fixed. Let me show you. We're going to say extends the product. And now we're going to pass on the name that we already know, which is Frappuccino. And the price is going to be 150. Okay, so now I've created the case class Frappuccino, which has the parameter flavor. And this is a subclass of products. And we pass on the name and the price like this. So let's just create two Frappuccinos, two class instances, two objects. First of all, a chocolate frappe, Frappuccino, and we only have to pass the flavor chocolate. And then we're going to do a caramel frappe, Frappuccino with the flavor caramel. Okay, now let's print them. Chocolate frappe dot. Now we know that we have access to the printMe function within product because Frappuccino is a subclass of product, so we have access to the fields and the methods. Method is the same as a function. I don't know if I've been using them both. Let me just write that down. Function is the same as a method in my vocabulary. So we're going to do printMe and the caramel frappe. Also printMe. Let's see what it gives us. 2 times a Frappuccino of 150. Now actually, I would like to use the flavor because these two are different and we're not really differentiating between them right now. So let's just add it to the name over here, right? Because we know what the flavor is. So we can just make an interpolated string of this. Let's try that. And now we have a chocolate Frappuccino and a caramel Frappuccino. Let me give this a capital letter, otherwise it looks kind of weird. Perfect. Okay, subclasses can actually add their own methods, just like normal classes. So let's see that, for example, for the class coffee, which is going to receive a Boolean caffeine, whether the coffee has caffeine or not, we're going to extend once again the products class, and this time we're going to pass the name coffee and the price is 1, and we're going to add a function in here which is going to be strength. So the coffee strength, if caffeine, so this is either true or false. If it's true, then we're going to say this coffee is quite strong, and otherwise we're going to say this coffee is not strong. Now actually for the taste, I think without caffeine it can still be strong, but this will be strong in the sense of it wakes you up, it keeps you awake at night, okay? So we have the class coffee, which is now a subclass of product because we extended product, and it has its own function strength, and it also has access to the function that we already had here within the class product. Let's create 2 coffees. We're going to create a normal coffee, which is coffee, and then we would pass the boolean true. Now you could just do this, but I don't like that. I prefer to write what the boolean is for. So this is just for clarity. You're not defining anything specifically. This is just like a label. You can see it as a label. Because if you don't have this label, it might not be that clear like this. You're like, true? What is true? Caffeine is true, okay? And then we have a decaf coffee, and that will be an instance of the coffee class with caffeine is false. Let's print both of them. Normal coffee prints me, and decaf coffee prints me. So we have twice the coffee, and now we're going to try out the other method that we had. Normal coffee dot strength and decaf coffee dot strength. And the first one prints this coffee is quite strong, and the second one, this coffee is not strong. I see that I wrote coffee twice with only one E. So that's an example of the fact that subclasses can have their own methods because they are simply normal classes, and subclasses can also override the functions that they inherit from the superclass. Let's look at an example. We're going to create the class cookie, which will have a cookie type. We're going to extend the product once again, and we'll do something similar as we did with the frappe. We're going to combine the cookie type with the word cookie. So first we say cookie type, and then cookie, and the price is 75 cents. And now we're going to override the method that we already had, which was print me. So I wrote down first override, then the same definition as we had before, and this time I'm going to print it's a cookie, and then the cookie type. So now I've changed the print me method. Let's try this. We're going to create a chocolate chip cookie. It's a cookie with the cookie type chocolate chip. And now we're going to try the print me method. And as you can see, it prints the string that we defined right here, and it disregards the method that we had here because we did an override of that method. So cookie is still a subclass of product, but the print me method has now been overridden. Now all of these cookies and coffees and frappuccinos that we made, we can actually make one list of that because they are all products. So we can make one list of products, and we can put in that list all the items that we made just now. Why? Because the frappuccino, the coffee, and the cookie are all subclasses of product. So that means they are a product, but more specifically, they are a frappuccino, or they are a product, but more specifically, they are a cookie. Let's just print the list. Print products. And as you can see, we have one list with a frappuccino chocolate, frappuccino caramel, a coffee, not another coffee, and then a cookie. And over here, I explicitly stated that the value product is a list of products. And if one of these items would not have been a product, then the compiler would have given me an error. That's why you can see that all of these values are also products. Now let's add on some information because, for example, I can decide, well, my product also has a Boolean, which is takeaway, for whether this is a takeaway product or not. Now I have to add this Boolean somehow to my definitions below as well, because otherwise, let's just save this and you will see that it gives an error. It says here, not enough arguments for constructor products. So over here, you are using the constructor of this class, and it is expecting a name, a price, and a takeaway Boolean, and we are only giving the name and then the price. So we have to add the takeaway Boolean here. So what we're going to do is just add a takeaway Boolean here as well, and we pass that one on to the product. And now we have to add the Booleans also in the class instantiation. So once again, I'm going to label those Booleans as I did with the caffeine as well. So we're going to say this is a takeaway one, this is not a takeaway one. Let's see, this coffee, the normal coffee, that is also a takeaway. The decaf is also a takeaway. And finally, the cookie is not a takeaway. Now everything should compile again. Okay. Now, why did I bring us into this mess? This is to show that we can add some functionality to the product class, and then we benefit from that in our Frappuccino, coffee, and cookie class. So we're going to add a new method that is called print order, which will receive the amount, so the amount that has been ordered. And we're going to say, well, we're going to take the takeaway Boolean and the amount that has been ordered. And then according to this information, we're going to print the order. So we're going to say, well, if it's a takeaway and the amount is equal to 1, then we're going to print whatever product it is, to go. Now, in the case that it is takeaway, but there is some other amount that has been ordered, we're going to print number times name to go. Then we have the case that it's not a takeaway and it's only one item. Then we're going to print a served something. So that means that you serve it out right away. And in the other case, we're going to print an interpolated string, number of times name served with R. Now, as you can see, I'm repeating the print line here over and over and over again. I don't really like the look of that. So what I'm going to do is I'm actually going to create a string first, and then at the end, we're going to print it. So here we're just going to create the message. And we can do it like that. Then I'm going to remove all this print stuff because we're only putting a message in that value. Like this. So now you can see that this whole part will give some sort of result, and the result is just going to be stored in message. So message is going to be a string, and we can simply use that, and we're going to print it over here. So in programming, you're always going to want to avoid duplicate code. So in this way, we're not writing print line 4 times. Well, I actually did, and you probably did too, but this is actually much faster. Let's try this out. For example, we're going to take the chocolate frappe, and we're going to say print order, and we're going to order 1. Now the frappe was a to go, the chocolate frappe, so it prints a chocolate frappuccino to go. Let's print 3. 3 times chocolate frappuccino to go. Isn't this super cool? I think this is really cool. Okay, now the chocolate chip cookie. We're going to print 5. And the chocolate chip cookie had the takeaway boolean set to false, so it's served. So we have 5 times chocolate chip cookie served. And let's do 1 a served chocolate chip cookie. So this was just to illustrate that by adding one method to the base class over here, the superclass, we can use that in all the subclasses as well. And that's super convenient. Let me just go back to this naming. I don't want to confuse you, but I also want you to know that there are multiple ways to name this. So we have the superclass and the subclass, but as I just said as well, I said base class, and then you would say for the subclass, you could call it the derived class. So there are simply different ways of describing this, but the principle is always the same. You have some sort of parent and some sort of child, and you just have to understand that relationship. So the most important thing to remember is that the child inherits all fields and functions from the parent, and then as we saw after that, a subclass can still create also their own methods, and a subclass can override methods from the superclass. Now, let's look at the task that you are going to do. I'm going to copy all the information. You will be applying all your inheritance knowledge to help out a travel agency storing information about their travel packages. Each travel package has a name, a price, and a destination. And then there are 3 different types: the tropical jungle, the snowy week, and the city tour. And each of them has some extra parameters that the simple travel package doesn't have. So the first thing you're going to do is create all necessary classes using inheritance, and create at least 2 class instances, so objects, of each different travel package, so you have some data to play with. Then, in the travel package class, so that would be the superclass, you're going to create 2 functions. The first function is to print information about the particular package. So it will be some string like that. This amazing travel package X goes to X and costs X. So fill in the X's. And then the second function will be that given a paid amount of money, how much will be the change that a customer receives. And then you're going to do some extra stuff. For example, in the city tour class, you're going to add a function that returns the amount of cities that will be visited. In the snowy week class, you're going to add a function that returns information about the temperature. So I wrote down here what the strings are going to be. When the temperature is below -20, the information is going to be extremely cold. When it's below 10, it's going to be super cold. When it's below 0, it's going to be quite cold, and otherwise it's going to be not that cold. And finally, in the tropical jungle class, you're going to override the function that prints the information about the package, and you're going to change it to ready for the jungle. We are going to price, fill in the blanks once again. Okay, so just to play and practice with all that we've seen today. So now you know all the basic stuff about inheritance. Good luck in the assignment, and I will see you in the next video.